Okay, so where are we at this point? Start with y equals 2x squared plus x cubed. Following the bullets on the problem as specified, we get our y equals x squared points for the specified x values, right? Then we get the x cubed values, and we go ahead and plot the x squared in the x cubed function between -2 and 0. And then we kind of look at the way they would extend, okay? Then we double the x squared values, get these values and plot those. So there's our 2x squared graph. And we observe that, this point here is, well, we do an arrow from here to here, an arrow from here to here, because this arrow would represent the value of the x squared. If we have two of them, then we represent the value of 2x squared. Here, the value of x squared, another arrow the same length will get us up to the value of 2x squared. Here, the value would be up here someplace, so I didn't draw it. Then the x cubed values, of course, are what they are, and the -8 is down there too far, but we see where this is going. Okay? Then we add the two. So at this point, the 2x squared value would be indicated by a green arrow here, the x cubed value by the green arrow here. So we put these two green arrows together, this one, and then we do this one, which brings us back down to here, right? And then we do the same thing, okay? Here we have a little, really tiny green arrow. Here we have a bigger green arrow. And we put the little tiny green arrow together with the bigger one, and we get this point. And then we would do the same here. This arrow would be all the way up like here, and then we got an arrow down here that's equal and opposite in length, and it gets us back to the origin, right? That's a picture of adding two graphs. And you might have to do it from two graphs. You might have to do it by making a table, or you might just have a free problem where you can do it one or both ways. Okay, so now we've constructed the graph of our f of x function. We're not sure exactly where the graph of the f of x would peak, but it's got to be going up here, and then at some point turn around and come down here, right? Okay, so really it kind of curves upward a little bit here, but at some point it starts curving downward. And then what happens? Well, the x cubed values are going to get much bigger than the 2x squared values. For example, you just calculate for x equals 3, x squared would be 9, so 2x squared would be 18, right? But 3 cubed is 27, and so of course it'd be -3 cubed, okay? It'd be -27, so we'd already be down 9 if we just move over one more. So our green graph is going to pretty quickly follow the trend of the x cubed graph, because x cubed, the cube is a higher power than the square. Well, here we get an idea what we mean by power. That means when x gets big, this thing's a lot more powerful because we're multiplying that big number by itself 3 times instead of twice. Even if we got a 2 in front of it, that's not going to help. This one is going to overpower any multiple of this one if you go far enough. So something you kind of want to think about. Anyhow, this is going to kind of go down like this, and it's going to get steep. Okay? So there is two pictures. Here we have two pictures of the construction of the graph of this function. Okay? Now what's going to happen after 0?
It's going to increase.
Well, both of these are going to be positive, right?
Yeah, it's going to increase.
Okay? And the graph is going to be a little bit above the graph of whichever one you want to choose, because they're both positive, right? If you do the arrow thing, like, the arrow here would go like this. I didn't do this very accurately, but your graph would be up here, right? Which is above either of the graphs. So the graph is going to go kind of like this. Okay? And now we have a picture that pretty much tells us what happens to the graph of the whole function, right? pretty uninteresting after we get here because we know it's just going to shoot upward. Never going to get vertical, but it's going to get very steep. Okay? And over here, we know that the graph is going to end up shooting downward because this thing's going to overpower anything that happens here. It's in between, in this region here, that all the interesting stuff happens. Okay? So we see, again, illustrating how we would put two functions together by addition. Another way we could have stated this is find h of x equal f of x plus g of x, right? Where okay, if I stated this problem like this, that would mean just do exactly what we did. Now, eventually, you would have to give a little thought to, well, what kind of x values would we use if we did the table? If it's basic functions, it ought to be pretty obvious, okay? Or if you have the two graphs, if I just say, okay, where f of x is given by this graph and g of x is given by this graph, well, then you do the thing with the arrows. Make sense? Okay? So hopefully we can do this, because combining functions is a big deal. You've already seen the functions that most functions that you deal with in this course or in any other course are built from. They're built by adding functions, your basic functions. Okay? Or adding multiples of your basic functions, or subtracting or multiplying your basic functions. We're not going to deal with that right now, but you could write it out. In other words, what would f of x times g of x be? Well, x squared times x cubed, 2x squared times x cubed is 2x to the fifth, right? What would f of x divided by g of x be? Well, 2x squared divided by x cubed, that would be 2 over x, wouldn't it? Okay? And those are important functions. And we have to see how they relate to each other. And also we have composites, f of g of x. Okay? Which would be pretty simple in this case, or g of f of x. So we'll be building new functions from the functions that we started with, mostly from those functions. Now we could use higher powers. We did x squared and x cubed. Well, it becomes pretty easy to understand x to the fifth or x to the eighth. Okay? And we'll be doing that.